Hi everyone. I figured I'd do a quick video on um, just the motors themselves, the specific motors, and break a couple of them apart to show the inner workings of the gearing that's involved in them. So let's start off with we grab this, for instance. This is a Go Builder motor. It's This is the torque one, I believe. It's serial number 2025, represents the number of teeth in the spline on the output shaft. We'll go into that in a minute. And 2 is the generation of motor. So let's see what comes in this bag here. So we get the motor, of course, and it is the Go Builder torque motor. And we also get this little accompanying bag of what they are, horns. And these are actually critical because the horns, these are these black pieces right here, they act as the go-between the output shaft and how you're going to mount something to your motor. So I guess it's like an interface, and they're actually important. If you look at the output shaft on the Go Builder motors and the Spring RC, that's this black one right here. The output shaft has a spline, and the horn themselves has the accompanying spline that when they're joined together and a screw is used in the face of this to hold it on, you have power transmission right there through the output shaft into the horn, and then the horn mounts to whatever you're trying to drive. The spline, try to look at it under the zoom here, you can actually see the spline on the output shaft. That's right there. And take note of the threads that are inside the ID of that, right? Those are 3mm threads. The 3mm threads are, that's the screw you're going to use to hold the horn on, or an adapter. And the Spring RC also has the spline coming out of the plastic output gear, a little less pronounced, right? So it's still a spline though, and it works, but it's not quite as robust as the Go Builder motor. So the other motor that's available to us is just what they call a simple gearhead motor. And what that means is you have the motor, and then you have the gearhead assembly. So it's constant RPM into the gearhead, and that's going to translate into whatever the rotational speed is, based on what the gear configuration is. The LDO motors, that's what this one is, they actually come in 5 different configurations, so gear configurations. So we go from everything from low torque all the way up to high torque, and then the 3 that are in between those two. It's progressive as it goes up, and these are really handy. You can program these through a motor controller, VEX motor controller, it's called, and so they're pretty handy. They're pretty robust motors too. They can take a lot of abuse. So let's see. Let's go back to what was in the baggie here. You're going to see a lot of components that you're probably not going to use, but I'll explain them. And you'll see the first component I got in my fingers here is a little rubber grommet, and that acts as like a buffer that goes into the mounting hole of the motor. And they did something kind of fun here, is they have a sleeve that goes inside of that also. So now you have this configuration, and then they offer you the option of using a self-tapping screw. You can see the difference between these two right here, a self-tapping screw and a machine screw, right? And what that affords you is you can actually mount your motor, and the rubber grommet acts as a dampener for vibration or motion. So that's kind of a handy little thing if you choose to use it. From experience and history, it, I prefer more of a mechanical mounting, like right through your components and then a nut on the other side. I think that works just fine. But those kind of neat. So when you see those in your baggie, you know what they're for. Um, the output shaft I mentioned earlier, right? That is a 3 millimeter thread, and you would put a screw right through the center of the horn, for instance, and then that would mount it right on there, and it wouldn't be able to pop off. So that's what's in our bag of horns that accompany all the motors. So let's go over here, and I've taken the time to take screws out of the motors. Now, for the Go Builder series, we have the torque and the speed. Um, if you're looking to use these as a drive wheel, per se, maybe the speed is what you're looking for. If you're looking for lifting and pushing capabilities, then maybe the torque would be the end. But I'll show you what the difference in these two are. Now, the motors are the same. The input voltage and the motors are all going to be the same on these two. It's just the gear configuration is a little bit different in each one of these. And again, that's the whole gear ratio thing that's in another video kind of explains how you can get different output speeds or torques on the shafts. So here I have the gearbox that's in each one of these. It's kind of impressive, huh? The Go Builder does a really nice job. They have all steel gearing, so they're very robust. Also, Go Builder does a wonderful job. They're very generous with their information on their websites. You can get the entire spec sheet on each one of these motors just by going to the Go Builder website. Pretty impressive, the work they do. So kind of look at a little bit of close-up on that there on each one. Nicely constructed, huh? Okay, so the one here at the bottom of the screen is actually the high torque motor in comparison to the high speed motor, which is at the top of this view on the bottom corner here. And you can see the difference between the two is actually the size of this gear here and the size of the output gear that's attached to the motor. The motor is in this end of the housing, and you can see the output shafts right here. So that's what gives you the difference between speed and torque. The motors and the voltage are always the same. It's the gearing that changes that. Now the spring RC is basically the same configuration. You can see here it's got the same configuration. It's just obviously the difference is the plastic gearing and such. So a little less robust than, let's say, the Go Builder, but they're still quite durable for what they are. They have a spot here that you can access the pot that would give you positional change on the rotation on this particular motor. If you look on the bottom side of this, you'll see that's the motor end of it right here. You see it has the board, and the Go Builder is equipped with, actually, if you look down inside, that's a shaft encoder that tracks the rotation of the output shaft and position. That the Go Builder is equipped with that because it can go from a servo to a continuous just by changing its configuration with a board they supply. Whereas the spring RC, I should say, is pretty much just it. It's a servo. So that's kind of the gearing difference on those. Let's take a look in the LDO motor. I'll pop the top here in the close-up. It's kind of neat. You'll see down here inside, you'll see the pinion gear that's attached to the motor. So that's going to be a constant. And then this is kind of neat here, this setup. If you look, you see all this gearing that goes on, and the pinion gear makes contact with this one, I believe. And if you look, I'm effortlessly spinning these gears. And then if you look on this end here, you'll see the flat on that output shaft come around. You can see I'm turning the gears at a certain rate, and you'll see how slow that output shaft is actually turning. Again, that's all done through the gear reduction on the gear train or transmission that's involved. So there's a lot going on inside these little guys, and it's kind of fun, rather than just grab one, plug it in, and use it. It's kind of neat to see what's going on in there. If you choose to take one apart, I'm just going to caution you that you got to be a little bit delicate with them, and because the gears do just come off if you want, right? But you just have to keep track of that, because you can put them back together as long as you're careful about it. So I guess that's it for these motors. Hopefully that helps.